Hello everyone, welcome back to a new video. In this video, we're going to solve practice 4D. Now we have the first question. It says, gas in a container is at a pressure of 1.6 times 10 to the power of 5 Pascal. So we have pressure, which is equal to, let's write the givens. Pressure is equal to 1.6 times 10 to the power of 5 Pascal. And a volume of 0.4 meter cubed. What is the work done by the gas if it expands, part A, if it expands at constant pressure to twice its initial volume? What was the initial volume? The initial volume was 4 meter cubed. So initial volume is going to be 4 meter cubed. It says the gas expands twice its initial volume. So this is going to be what? This is going to be V final, which is going to be 2 times the initial volume. 2 times 4, it's going to be 8 meter cubed. Now, part A is going to be what? It says how much, what is the work done by the gas? So we know that work is done by the gas, and work is equal to what? Pressure multiplied by delta V. Pressure is going to be what? 1.6 times 10 to the power of 5 Pascal. Times delta V is going to be final minus initial, so 8 minus 4, then 4, you basically get 4 here. So this is going to be 6.4 times 10 to the power of 5 joule. This is the work done by the gas. This is part A. Part B, it says, if the volume, it says, if it is compressed, if the gas is compressed at constant pressure to 1/4 of its initial volume. So part B is going to be what? V final is going to be 1/4. How do you write 1/4? 1/4 times the initial volume. Initial volume is equal to what? It's equal to 4. So 4 cancels and you have V final, which is equal to 1 meter cubed. Remember, in the previous lesson, we said if the gas is compressed, then work is done by the system, okay? Work is done, on the gas. The gas is not doing work. Work is done on the gas. So we should get a negative result. Let's check if it's correct. Work is going to be pressure multiplied by delta V. Then pressure is going to be what? 1.6 times 10 to the power of 5. Volume is going to be what? Is going to be, remember, final is equal to 1, and then initial is equal to 4. So we get a minus here. It's going to be minus 3. Okay? Multiply all of this, and work is going to be minus 4.8 times 10 to the power of 5 joule. This is negative. This negative only means that work is done on the gas. It's compressed. In the previous question, work was done by the gas and gas was expanding, okay? Now you have question 2. It says, a gas is enclosed in a container fitted with a piston. The applied pressure is maintained at 500, so pressure is equal to 599.5 kilopascal. Directly change this to Pascal. We need the result in Pascal. So 599.5 times kilos 10 to the power of 3 Pascal. Which changes the volume of the gas from, careful, whenever it says from a number to a number, this from is going to be initial, and 2 after 2 is going to be final. So it says the volume of the gas changes from, so V initial is going to be 5.317 times 10 to the power of minus 4, and V final is going to be what? V final is going to be 2 point, so the volume changes from this one to this one. Let me write the unit, so meter cubed. So V final is going to be what? 2.523 times 10 to the power of minus 4 meter cubed. How much work is done? It says how much work is done is the work done by the gas or on the gas? Remember, work is done on the gas if the result is negative, and gas is doing work, or work is done by the gas if the result is positive. Let's see, what do we get? You can basically see that V initial, V final is smaller than V initial, so it's going to be a negative result. So W, which is work, is equal to pressure multiplied by delta V. Pressure is 599.5 times 10 to the power of 3 times final is equal to what? It is equal to 2.523 times 10 to the power of minus 4 subtracted by 5.317 times 10 to the power of minus 4. Calculate all of this and you should get work minus 167.5 joule. This minus shows what? It shows that the work is done on the gas. We have question 3. It says a toy balloon is inflated with helium at a constant pressure that is 4.3. So you have pressure, which is equal to 4.3 times 10 to the power of 5 Pascal. In excess of atmospheric pressure, if the balloon inflates from a volume, again we have from and we have to. So from, the initial is going to be what? Is going to be 1.8 times 10 to the power of minus 4 meter cubed. V final is going to be what? Is going to be 9.5 times 10 to the power of minus 4. Now it says how much work is done on the balloon by the helium. So it has already told us that helium is doing work on the balloon. So we know that we're going to get a positive result. And this is larger than the initial one. So of course we're going to get a positive result. So work is going to be what? Pressure multiplied by delta V. Pressure was equal to what? Pressure was equal to 4.3 times 10 to the power of 5 times 1.8 times 10 to the power of minus 4 minus 9.5 times 10 to the power of minus 4. You get work which is equal to 331.1 joule. It's positive because work is done by the helium on the balloon. You have question 4. Question 4, it says a steam moves into the cylinder of a steam engine at a constant pressure, does work of 0.84 joule. So this is what? This is work. Work is equal to 0.84 joule of work on a piston. The diameter of the piston, so we have diameter, which is equal to what? Diameter is equal to 1.6 centimeters. D is equal to 1.6. I'm going to write this in capital because you'll be having another quantity too. 1.6 centimeters. Make sure to change this to the radius, which is going to be what? Radius is going to be diameter divided by 2. 1.6 divided by 2 is 0.8 centimeters. And then change this to what? To meter. This is going to be 0.8 times 10 to the power of minus 2 meter. Okay, this is our radius, careful. Okay, then what else do we have? It says, and the piston travels 2.1 centimeters. This is D2, but this is what? This is the distance that the piston has traveled. What is the pressure of the steam? So P is equal to what? First of all, you might say, why do we need the radius? Okay, you will just know in a minute. Okay, so work is equal to what? Is equal to pressure multiplied by V. What are we trying to find here? We are trying to find pressure. So pressure is going to be what? Is going to be work divided by, so to basically divide this. Let me do this. So unit pressure, so divide this by delta V and divide this by delta V. Cancels, cancels, and then pressure is equal to what? Is equal to work divided by delta V. Now guys, do I have volume? No. But do I have another equation for the volume? Yeah, we studied that in the previous lesson. Work divided by area multiplied by distance. It's the same equation. Now remember, area was equal to what? Area was equal to pi r squared. That's why I need this radius. Okay, then it's pretty easy. So this is going to be what? This is going to be 0.84, 0.84, which is the work done by the piston, divided by area is going to be what? Is going to be pi multiplied by 0.08 times 10 to the power of minus 2. Make sure to square this. This is squared. Okay, times distance was equal to what? It is equal to 2.1 centimeter. Make sure to change this to meter. 2.1 times 10 to the power of minus 2 meter. So 2.1 times 10 to the power of minus 2 meter. Calculate all of this and you should get 2, this is rounded up by the way, 2 times 10 to the power of 5 Pascal. This is the pressure of the piston. This is it for today. See you in the next video.